know what a slide through this world. Well, I don't know what it was too. This one could be with you. What a wonderful world this would be.
Hey everybody, great to see you. Welcome back to Mr. K's 30 Minutes of Math. It is a beautiful sunny day today, a little bit cool, but still a great day for getting outside. I hope you are all doing well, and let's get started. So first up is our riddle from yesterday. Let me stop the video so I can pay close attention. Hold on one second. All right, so this was an interesting one. Let me read it again just to catch everybody up. If you have 5 people in a room and each person shakes hands, now mind you, there's not going to be any shaking hands right now during the coronavirus, but let's suppose we were not in the coronavirus. All right, so each person shakes hands with every other person in the room exactly once. How many handshakes would occur? How many handshakes would occur? So I'm curious to see if anybody had any answers. Delilah writes in that we would have 10. Anybody else have any ideas how many different handshakes we would have? Curious to see. I see Ezra writing in with 10 as well. Well, let us take a look. Are you ready, ladies and gentlemen? Well done, that is correct. It would be 10 handshakes. And let me take a second to just explain that. So let's pretend we have 5 different colored dots representing our 5 different people. We have a green dot, a blue dot, a red dot, a purple dot, and maybe a light green dot. That's what we'll go with. And we can represent them, their handshakes that is, with lines. So let's start with the red dot, this guy right here. All right, so let's say she shakes hands with the blue dot, and then the green dot, and then the light green dot, and then the purple dot. So that's 4 handshakes. Okay, let's go to the purple dot. Let's get a good purple. Let me see if I can find something good. How about that? All right. Well, she's already shaken hands with the red dot, but she hasn't shaken hands with the blue dot. So there's another one. She hasn't shaken hands with the green dot or the light green dot. All right, so that's 3 more. Okay, let's move on to the blue dot. Well, the blue dot already shook hands with the red dot and already shook hands with the purple dot, but has not shaken hands with the green dot and has not shaken hands with the light green dot. So that's 2 more. All right, let's go to the green dot. The green dot has shaken hands with everybody already except the light green dot. That's 1 more. And the regular green dot has now shaken hands with everybody. The light green dot has shaken hands with everybody. So if we add up 4 plus 3 plus 2 plus 1, we will get 10. Well done. Very impressed. Very, very impressed. Good job, everybody. All right, let's dive into last night's homework. We were completing number sentences, and we were using our very large brains to do so. As you may recall, we started here with 3 and 5/6. We have to add something to make 4. Well, we know 3 and 5/6 is just 1/6 away from having another whole, so that's what we would have. For B, we have 5 and 3/7, and we're trying to get to 6. Well, how many 7ths do we need to turn this into 1 more whole? How many more 7ths do we need? Go ahead, type it in. If we have 5 and 3/7, how many more 7ths do we need to get to 1 more whole? Well, we would need 4 more 7ths, because that would give us 7/7. So there you have, whoops. Let me write that again, 4/7. Well done. All right, down here we have 5 equals 4 1/8. And we want to get that to become 5. So how do we turn this 1/8 into a whole? Well, we're going to add 7 more eighths. Very good. And the last one, we have 15 equals 14 4/12. So again, we want to turn that into one whole so that we have 14 and 1 more. If we have 4/12 and we want to get to 12/12, then we have to add 8 more 12ths. And Delilah, you are correct. That is the same as 2/3. Well done again. Well done. All right, now what we'd like to try to do is something that's similar, but a little bit different. We're going to add with rounding. So what I want you to do is estimate each sum or difference to the nearest half or whole by rounding. So you're not looking for the exact answer, just for an estimate. We want it to be as close as we can to the nearest whole or the nearest half. So let me give this a try. First to start, we have 2 1/12. Well, 1/12 is pretty close to 0. So let's just cancel that out as we're rounding. It would be very close to 2. And 1 7/8, well, we know 7/8 is pretty close to 1 whole. So let's turn this into 2, and we would get 4. Another way to show that is we could use a number line. For example, 0, 1, 2. 1 7/8 is right here. And if we rounded that to the nearest whole, well, it absolutely goes to 2. And 2 1/12, well, 2 1/12, let's call this 3. I would have to split this up into 12 pieces. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 2 1/12 would be right there. And that is definitely closer to 2. So there you have it, 2 and 2, which would give us 4. All right, how about B? Let's take a look at that one. 1 11/12. 1 11/12 is almost 2, because we know 12/12 would be 1 whole, and we already have 1 whole, so that would give you 2. And then 5 3/4, 1, 2, 3, 4, 5, 6. 5 3/4 would be right there. Definitely closer to 6 than it is to 5. And so our estimate would be 8. All right, I would like you guys to go ahead and try these. Just do estimates. Go ahead. Okay, welcome back, everybody. Let's take a look at these. I see some of you writing in your answers. That is always wonderful to see. We're going to start right here, 3 1/10. 3 1/10. Well, if I was doing tenths, I would have to split this up 3, 4, 5, 6, 7, 8, 9, 10. 3 1/10 would be right here. Definitely closer to 3 than it is to 4. And then 1 3/4. I just realized something pretty funny, folks. This number line didn't have a 1. So let me fix that, because that definitely, whoops, is not very accurate. There we go. Now I feel much better. All right, 1 3/4, this one. Well, here's 1, here's 2. 3/4 would be right about there, 1 3/4, that is. That is definitely closer to 2. And so if we have 3 and we have 2, we put them together, we get 5. Well done. I saw folks write that in. Okay, now what about B? 2 9/10 is very close to 3 wholes, and 4 4/5 is also very close to the next whole, which would be 5. And so yes, we would get 8. Well done. I'm so happy with the work you guys are doing. All right, let's do some subtraction. Go ahead, same idea with rounding. Go for it. Okay, welcome back. Thanks so much for writing in. I see a number of you wrote in for C. It would be 7. Let's check it out. 8 7/8. I realize I need this line to be a little bit longer. 8 7/8 would be, let's divide this up. Oh gosh, they're super tiny. 8 7/8 would be right here, which is almost 9. And 2 1/5 would be right there, which is pretty close to 2, definitely closer to 2 than to 3. And so 9 minus 2 equals 7. Well done, guys. And then D would be 6 1/8. Let me use the same number line up here. 6 1/8 would be, let's get all my marks in. 6 1/8 would be right there. Definitely closer to 6 than it is to 7. And 2 1/12. I'm not going to be able to draw all those little lines, but I think we can agree it would be very close to 2. So there you have it. 6 minus 2 equals 4. Excellent. I am so proud of you guys. You guys, I got to bring back the video so you can see me smiling. I'm so proud of you. You guys are rocking it. Let's get to our joke of the day. Everybody ready? Here we go. Why did 7 eat 9? Now, I'm sure you all know the joke, why did 6 eat 7? Yeah, why did 6 eat 7? Because 7 ate 9, ha 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 ha. But why did 7 eat 9? That's the question. Why did 7 eat 9? Let me give you some Jeopardy music to think that one over. Okay, are you ready? Here's the drum roll. Why did 7 eat 9? Because you're supposed to eat 3 squared meals a day. 3 squared meals a day. Yes, that's kind of a groaner. If you haven't heard the phrase 3 square meals, that means 3 complete meals a day. But this little joke says 3 squared. Now, you should remember from some of our earlier lessons, 3 squared is 3 with that little 2 up there, which means 3 times 3, which equals 9. And that is why 7, 8, 9 to have is 3 squared meals a day. That reminded me of some of the work we were doing with our squares, but also our, remember these guys? The square roots, which goes the other way. So I thought we'd do a little bit of practice. Can somebody write in what would 8 squared be? And just to remind you, that's 8 times itself. What would 8 squared be? Folks could write that in. That would be wonderful. Let's see what folks come up with. Lots of 64s. Excellent, of course. Well done. All right, how about 11 squared? Let's see what you come up with there. Anybody know that one off the top? 11 times 11, which equals 121. I'll do that multiplication real quick right here. 1 times 1 is 1. And 1 times 110 gives us 1 more 10. Then I'm going to do our tens. 10 times 1 gives us 110, and then 1 more 10, and there we have it, 121. Okay, how about 15 squared? Anybody know that one? 15 squared. Let's see. I'll give you a second to check that one. 15 squared. Well done. That would be 225. So, friends, this is the full chart of the perfect squares for the numbers 1 through 25. I will tell you, it is very helpful. I'll bring the video back to memorize these. They come in really handy in lots of different situations in math. Certainly, you know all the perfect squares up to 10, but I would try to memorize them at least up to 15, maybe up to 20. They come in very, very handy in class. Now, what I also want to remind you is about our square roots. So let's take 36. Remember this sign, our square root sign. The square root of 36 is 6. That is telling us what number, when I square it, gives me 36. Same way that the square root of 100 is 10. What that's saying is, what number, when I square it, will give me 100? That's 10. So, ladies and gentlemen, what is the square root of 361? Look at your chart and type it in. What would the square root of 361 be? Go ahead, check your chart. What would the square root of 361? Another way of saying that is, what number can you square to get 361? You guys got it, 19. Brilliant, brilliant. What would the square root of 529, what would that be? The square root of 529. See if folks can type that in. Henry comes in with 23. Well done, well done. All right, so now what I want to test you out is to see if you can do some estimating. So let me start you off. What is the square root of 4? Can you type that in for me? What's the square root of 4? Not 16. Remember, what number do we multiply by itself to get 4? There you go. And what's the square root of 9? I see lots of T's there. What's the square root of 9? Not 4.5, it's not half. It's what number do I multiply by itself to get 9? There you go, 3. So here's my question. Would you say the square root of 5 is on a number line? Would you say it's in the yellow section or in the red section? The square root of 5. Would you say it's in the yellow section or in the red section? Delilah says both. Interesting. Anybody else have any thoughts? Let's see. Ezra says yellow section. Let's see. Anybody else have any thoughts? Well, and it's okay to not have any idea. Well, we know the square root of 4 is 2. And we know the square root of 9 is 3. The square root of 5 would be a little bit more than 2, but not all the way up to 3. So it would be in the yellow section. We can also test it out by doing 2.5, which is 2.5 times 2.5, and see what we come up with that. And I can do that real quick. I know we're not really doing decimals right now, but I'll show you. And I'll keep going. Whoops. And that would give you 6.25. I'm sorry, yeah, 6.25, which is a little bit more than 5. So we know the square root of 5 is closer to 2. I know that was a lot to kind of absorb, very complicated, but just wanted to give you a little bit of an extension today. All right, let's move back to our adding and subtracting. Now we're going to use benchmark numbers. Remember, by benchmark numbers, what we mean is we're looking to see, are we closer to 0, a half, 1, that sort of thing. And we can look at each of our problems to try it out. So, for example, 14 3/4 plus 29 11/12. Well, 14 3/4, we can round that up to 15. And 29 11/12, that's really close to 30. And so if we added those up, we would get 45. Go ahead and work on B, C, and D, and we will be right back. Okay, welcome back, everybody. Let's take a look at these. It is totally fine if some people went fast, some people went a little bit slower, some people feel like they're getting it, some people are still struggling a little bit. That is no problem. So let's start with 3 and 5/12. 3 and 5/12. So my question is, how many twelfths makes 1/2? How many twelfths makes 1/2? Everybody can write that in. How many twelfths makes 1/2? Well, if we had a number line and we split it up into 12 pieces, right in the middle would be 6/12. That's what half would be. So we know this is 3 and 5/12, which means it's pretty close. By the way, that means pretty close. That doesn't mean exactly equal. It means almost 3 1/2. And then our 54 and 5/8, again, if we had eighths, 0 and 1, right in the middle would be 4/8. And 5/8 is pretty close to that. So we could call it 54 1/2. And so if you added those, 3 1/2 plus 54 1/2, you'd get 58. Now, if you wrote in 57, that is completely fine. That is close. But I would push you to think 3 and 5/12, even if you didn't do the halves, that's closer to 3 than it is to 4. And 54 and 5/8 is closer to 55 than it is to 54. So really 58 is where we should land. Okay, C, let me erase some of this so we have some room. All right, and let me use green. 17 and 4/6. Well, 17 and 4/6, we think about sixths, and right in the middle is 3/6. Well, 4/6 is definitely more than half, not quite 1. So we could go with 17 1/2 to round. And then we have minus 8 and 7/12. And again, if we looked now at twelfths, right in the middle, half would be 6/12. 7/12 would be very close to that. So we could go with 8 1/2. And so 17 wholes minus 8 wholes would be 9. And then we have a half minus a half, which is nothing. And so that would give you 9 total. All right, last one, 65/8 minus 37/6. Well, this guy, let's change this into a mixed number. 8/8 is 1 whole, and 64/8 would be 8 wholes, and then we'd have 1/8 left over. And then for our sixths, we have 37 of them. Well, we know 36/6 would be 6 wholes, and then we'd have 1/6 left over. That's pretty close to 8 minus 6, which would be 2. All right, I know that is a lot of thinking to do, but that's the point. And again, we're just trying to get folks, everybody listening, to think through our fractions from a conceptual perspective, so you really understand how they work. All right, here is your homework. Go ahead and take a screenshot or jot it down or take a picture. 16/3 plus 17/8, and then we have 2 more. You'll notice they've got that approximation symbol, which means you're estimating. You're not doing exactly equal. No, we're estimating. Okay, so go ahead and write those down. Now, time for your riddle of the day. And for this one, you're definitely gonna have to do a screenshot or take a picture so that you can print out the shapes, then cut them out. The goal is to put all 7 of these shapes together to form one perfect square. Obviously, it's going to be bigger than that, but there's a way to fit all of these shapes together to make one large square, a perfect square with no pieces sticking out the sides. So go ahead, take a screenshot, print it out, cut out the pieces, and work on that tonight. Take a picture, you could print that out, or you could just print your screen if you have a printer at home. If you don't, you can try to draw these. Just remember, take a picture so that you have a sense of the different sizes, because that's really, really important. By the way, if you do this, make sure to keep the pieces because we'll do some more puzzles with them later on. All right, everybody, have a great day. It's been so much fun to spend some time with you, and I will see you tomorrow. Bye.